I'm curious to see what's going to happen when I engage the entire side of this thing. But just go in like 25 thousandths or something like that, or 100 thousandths bite. Something not terribly big. All right, it's already been an extremely long road just to get one pass along the outside, which I'm about to complete. We're doing like 5/8, maybe 3/4 of an inch this last bit. It's actually going okay. So next time around, I'm going to do the full length of the cutter, but I'm only going to engage just the edge of the cutter, maybe take 1/10 of an inch off a pass. I guess we'll find out if that's doable or not. The finish is chattery, and of course it's a coarse roughing end mill, so that's a bit of an issue, but okay. Let's go in 1/10 of an inch. Let's start with 59 thousandths actually. Let's just do 59 thousandths, see how that works. I'm locking the axis. As long as I keep it under tension, it seems to be okay with this low RPM. It's going to take forever to do this. So this is engaging the entire length of the cutter, but we're only going in a tenth of an inch of material. Every time I spray that WD-40, the cutting gets noticeably, or the back force on the rotary table gets significantly lower. It goes down as I'm doing it. But we can get away with this, so we'll get there, it looks like. Oh God, I haven't even figured out how I'm going to tackle these side pieces yet. I think those are going to have to go in the conventional mill. This is the last pass, 25 thousandths. I'm a little concerned that it's not deep enough. Oh, never mind. There's enough engagement that that's going okay. You just got to be careful when you exit the cuts. Also, this flat should have gone away, and I wonder if that's because the bit is deflecting enough. The cutter is deflecting enough that it can't take a skim pass because of the kind of cutter it is. I'm also wondering if at really low RPMs I could actually use a regular end mill and get away with it. As I'm exiting a cut like now, I always apply the brake. Alright, so I just wanted you to see this actually mates up pretty darn well. Look at that. That's really good, actually. It's just this little flat area here, which is fine. I mean, so all of this should actually go back a little bit. I could do another 25 thousandths pass. That looks like it's going to take 100 thousandths, though, to actually touch. And that's actually a lot more material before you actually hit that. That's a good 100 thousandths. Huh. I don't know why it's off by 100 thousandths, because my calculations were done in CAD, and they should be spot on. It may be because the cutter bounces over this flat area here and can't actually bite because it's such a small cut. I don't know, I'm going to have to think about this, but for now, let's cut the relief, because that's the most essential part of this whole thing, and that's the part I'm most concerned about, actually. So I'm not going to full depth, going about 6 thousandths shallower than that. I'm using a 5/8 inch end mill, really slow RPM again. It's still struggling. I've got the brakes on, both sides, and it's still bouncing all over the frickin' place. It's a bloody nightmare. This table's horrible. Well, this was easily the hardest thing I've ever done. So I got end mill suck, even though I switched to an ER40 collet and cranked it as hard as I could. I don't have any Welding flat ones, so I had concerns about that. We got the radius right on the money, which is awesome. I still have to cut out these huge relief sections here so that this piece has a place to go, because right now I can't get it farther than that, but it's a great match for the curve, so that's good. And the height is right on the money for this bit right here. So I think we're good to go. I was all freaked out because I thought that there was no way I was going to be able to do this on the rotary table, but I forgot. I get to lock the rotary table off completely for this. Holy cow. Yeah. Push the whole table. Okay, so that ain't working, clearly. Try a different end mill. This is a fine pitch, which seems like it'd be worse, but well, this one seems to be working better. RPM 260. Flipped it 180, going the other direction. Last pass on the second side, and I actually like this curve, and it doesn't interfere with anything, so I'm going to leave it rather than coming straight out. I think it adds something nice look. Gotta sand it down to make sure it's not sharp, but other than that, I'm liking it. This part will be done, except I need to put it in the mill, and I need to take an inch off of this bottom part to this depth right here, this back depth here, so that I can slide spacers under there. In spite of having end mill suck here, it's still support on both sides, which is good. There's also a little bit of end mill suck down here, but that's still way within spec. So we can hold the part like this. As you'll notice here, there's a bit of a problem because this frickin' radius is different. It ends there. So hopefully we can align the parts like this, and that is my goal. It's sitting pretty darn well, and it fits symmetrically as long as you are off of this bit here. Other than deburring, we thought we were done with this part, but I need to relieve about an inch thickness of material underneath here so that the plates can slide underneath it for the shoe part of this. For spacing, I've got 1/2 inch and 1 inch plates that need to fit underneath. Otherwise, I was going to have to match this curve, which would be a lot more work. And coming up with this idea, I think, was a really good one. So we're going to remove that material next. Talk about luck. There's conveniently a line right here where the face mill went over in this direction, right where I need it to be. So this is where we need to remove the material, right here, inch thickness. So I'm going to go find a end mill, an appropriate roughing end mill, and see what we can do. I have a roughing end mill here that has a Welding flat on it. That's this little ground portion here. Now with my diamond abrasive on my surface grinder, I could put the same sort of flat on some of my carbide bits, which I should do, because when combined with this kind of holder, you can reduce the amount of pull-out potential for the bit because they're held in place and locked vertically rather than just friction on a very hard surface like carbide. So I should grind those in on my other bits when I get a chance. That would definitely improve things because we want to control the depth here. And again, I'm using my leather underneath there to protect from when occasionally you have this spontaneously fall out. But let's get to it. Since we've locked this end mill in place, we're going to try and remove it all at once. I don't have a powered Y-axis, so this is going to take a little while. Oh. Not sure what happened there. Maybe a smaller bite, I don't know. So here's interesting. I didn't lock my x-axis, and it actually pulled the cutter into the part. Since this thickness doesn't matter, I'm going to deck this guy off to clean up my screw up. Now all we have left is to deburr this part, and we're done. I cleaned up my mistake, which required another 125 thousandths. Still not sure how that happened. I tightened the part, knocked it in, and then it somehow came loose again. I'm still not sure, unless somehow I got a chip in there, but I always double check. I'm really not sure how it came loose, but that caused it to bite in 125 thousandths. This depth does not matter at all. We made this a little bit less strength by taking 125 thousandths or an eighth inch more material off. Still plenty beefy for what it needs to be. So I think we're good, especially since this bears against nothing. This material here, it's actually the ridge back here that takes all of the force. This actually takes none at all. We could have this a lot thinner and it would still function perfectly well, because again, no force along this edge. This is about 1/4 of an inch. Actually, it's 300 thousandths of an inch away from the part we're pressing on to this piece right here. Next up is the 1-inch base plate. We have to find the center between the two sides. It's actually, everything's based off the center line, so it won't really matter. We're gonna bore a hole in the center, and we're gonna drill the 4 holes to mount that, that piece that we just spent all that time making that will hold the webbing. And then you'll press the shoe from here. First up, I'm going to drill and ream a hole that'll fit a 3/8 inch dowel pin that I can use to locate all the other holes again if I lose them. These are just saw cut edges, so I don't really trust them. I found what I consider the rough center, which is, I don't know, plus or minus probably 1,000th or 2, but not over the whole length, potentially off by more than that. So it depends on where you measure. So instead, I'm going to create a dowel pin that I can come back to that'll be 2.5 inches in and exactly where I'm considering the center of all of my holes in case I need to come back. So that's the first thing we're going to do. We're going to replace this guy with the Tangent Engineering wheel. Huge improvement when you're drilling. I should have swapped right off the bat. I use it every time I drill, pretty much. Highly recommended. There we go. And that's a perfect fit. And if it gets stuck down at the bottom because it's a snug fit, because I drilled the slightly smaller drill bit all the way through, I can always punch it out from the back. But this gives me a reference point in the future. So I used an engraver, wrote 3/8 inch diameter, 2.5 inch center, and for that hole. This will be buried under the fixture piece anyway, so no one will see it but me in case I ever have to do something with this plate and modify it. That's just a fail-safe for me to come back to. I have a good reference point, and this is just a fixture anyways. First hole is the one I'm gonna need to make 1 inch diameter for the pin. And again, this could be a reference point as well, but I thought I'd add the other one because this one's I'm gonna leave a little bit sloppy so that the fixture can move it around a tiny bit. Okay, that's hole number 1. We're gonna come back to this and make it 1 inch later. By the way, that lettering that was on here that you saw is very acetone soluble, so just throw some acetone on there, it cleans it right up. I'm going to blow out these holes with the air compressor that can mount the piece I made, and then we can see if we can center up one of these guys. And I almost just made a ton more work for myself. Did you catch it by any chance? If you said, hey, you forgot to go back and make this hole 1 inch, you'd be right. I need to do that. I am going to try a shortcut, and shortcuts can always be problematic, so hopefully this one will not. I'm going to take a 1-inch end mill. I actually need this hole to be 1.03 inches, so it should be fine, because usually these things, when you bore with them, actually end up being oversized a little bit, so hopefully that'll work out. So to test my theory, we're going to go in just a little ways, which I didn't leave enough clearance to test this pin in there, but we're going to do it anyways. So we're going to go in a little ways, and then we're going to drop the table back down. Well, let's see, maybe I should plan on dropping the table down to begin with. All right, so we're going to go in a little ways and see how the pin fits. It should be overly tight. All right, let's see how she fits. Too tight. Ooh. I wonder if we could tap this guy in. That is really tight. All right, so this will work. If I have to, I can bore it slightly larger. That'll be a very quick operation. So there's enough force, I can see the end mill moving side to side a little bit, which might give me that 3/1000 I need. But look at that. That's that's exactly the fit I want. Just ever so slightly loose. That's perfect. That's exactly what I need. So when this thing pushes back, you can see there's not a lot of play here. So when you do put this fixture in, you just slide it back just ever so slightly so that this pin is engaged. And when all that force is pushing back, it'll push back on friction on the surface here and the bolts, as well as this pin here, which is just an added backup. I wanted it there also so I could use it as a locating point. So it's multi-purpose. I think we're good.